Restarting the simulation with the default values back in place, we can see that the shuttle initially spawns with a number of robots, a few of each type. Another thing which I've enabled is the ability for the shuttle to actually spawn new robot types. How this works is, after a number of rocks have been collected, the shuttle will then create a new robot type randomly selected from the 3 available. In this way we can watch as the swarm gradually grows and gathers more members, and see how seamlessly those members are then introduced into the community and into the network. This will also give me a chance to talk about some of the interesting features and emergent behaviours which I've noticed of the swarm as a whole. Firstly, there is a particular behaviour exhibited by the movement robots when retrieving rocks, whereby one movement robot will be in the process of retrieving a rock, and another movement robot, also moving to collect the same rock, will then appear to take that rock from the first movement robot and carry on with it, while the first movement robot goes off to complete another task. This sort of conveyor belt type behaviour is completely emergent and not planned in any way, and it simply arises from how the movement robots, see, we saw it just there, completely emergent from how the movement robots deal with their tasks and pick up objects and move them around and decide when tasks are finished. We can also see the benefits of a swarm type approach when faced with parallel type problems. See, whereas one very advanced robot may only be able to collect a few rocks at a time, because of the divided approach and the multiple robots, the swarm is able to collect large numbers of rocks in parallel, where a traditional approach might be limited in the amount of parallel functioning that it could achieve. As the number of movement robots within the swarm grows, the number of rocks which can be collected simultaneously also increases, meaning that this solution would also have scalability as well as adaptability to whatever problem they are faced with. What we're seeing here is an interesting behavior whereby scouts that become disconnected from the network will attempt to find their way back to the network by randomly wandering through the environment. If I create a scout down here, we will see the random wandering behavior. And this scout robot may eventually meet up with the rest of the network, or it may eventually simply run out of power or become damaged. One thing that you will notice with a larger swarm which has been left to run for quite a while is that the boundaries of the swarm become quite apparent. Robots within the swarm will eventually wear down and require repairs to keep functioning. But what happens is that because there are only so many movement robots within the swarm to retrieve these robots, robots that are left on the outside of the swarm won't be retrieved as often, and therefore the swarm can only grow so big before it's not capable of supporting a larger size due to the amount of time required and the amount of manpower required to be retrieving damaged bots backwards and forwards all the time. Another theoretical side effect of the way that these scout robots work is that when damaged robots are retrieved, those damaged robots are then pushed into the center of the network, and the functioning parts are pushed further out. This means that if an individual robot is particularly prone to breaking down, that robot will be a lot closer to the center of the swarm more often, simply because it's being pushed inwards every time it breaks down. This would mean that robots that require more maintenance would be closer to the source of the maintenance as a result, and robots which can function for longer but without breaking down would be pushed onto the outside rim of the swarm, where their extended lifetime can be put to greatest use. I initially started working on a contract net type architecture for how the requests were delegated to the robots, but found that that quickly became a little constricting, and I sort of naturally transitioned into a polling type request, whereby robots will keep asking for assistance until they no longer require assistance, and scouts will keep telling the network that there's rocks that need to be collected until those rocks have been collected. Lastly, I will say that this simulation was developed using C# and XNA. And that's about it. Thank you for watching this overview of my Swarm research project. I hope you've enjoyed me talking about the simulation that I've developed, how I developed it, what I was thinking. If you're interested in seeing the actual development process right from the start, check out my channel. There's a playlist of that process. I'll put a link in the description. If you have any questions or comments or feedback or suggestions or anything like that, leave them in the comment section down below. If you enjoyed this video, please give it a like, and check out my channel for updates on this and other projects, and subscribe if you want to keep up to date with future projects as they come out. Thank you guys for watching. I'll see you next time.